Hi, I'm Federica. I'm 13 years old. And I love anything regarding physics, mathematics, and engineering. So you know what? Imagine being at the start of a simple summer, more specifically of 2022. You don't know what to do. You start reading a book, and then you start rewriting what you understand from the book, only to end up writing one of your own. So on here, I'm going to essentially read what I'm the current book I'm writing, but it's still not published. But I'm gonna, for now, let's say read it here what I'm currently writing. um, so I say let's start. Let's start with something easy to explain, but maybe a little harder to understand. But I'm going to make it as easier as I can to understand. So in fact, we're going to start with Um, so we're gonna go back way back in 1927, um, where we come across the first announcement of the principle of uncertainty and the father of this theory, of course, um, Werner Karl Heisenberg. So he was a German physicist. So Heisenberg studied Bohr's. So what did Heisenberg do? So what he did was study Bohr's um, atom model, and he found some absurdities in it. Okay, he especially regarding the concept of the orbits. So let me explain. Bohr stated in his atom model that the electron moves around the nucleus in orbits, which it was right. But he already assumed that he already knew both the velocity and the position of the electrons at, at every time when uh, at every time when in movement. Heisenberg did not agree to that. Let me explain. So Heisenberg um, did understand the atom model and did agree to that, but um, he just found absurdities in the in because Bohr already assumed from the start that he knew the position and the velocity of the electrons, but Heisenberg uh, didn't think it was possible. And so what he did, he soon created the principle of uncertainty. The Heisenberg goal was to show that it was impossible to determine the position and the velocity of an electron going in orbits around an atom. So he said if we wanted to determine the position of an electron, we would have to emit photons which would interact with the electron, uh, distorting its trajectory, yeah, um, um, and uh, and charging its speed. But Heisenberg showed that it was impossible to determine exactly the position and the velocity of electron at the same time. How did he do that? So let's use the example of A times B equals 10, where A equals 5 and B equals 2. So if we still want the result of 10, we would, so if we want to still have the result of 10, but changing both A and B, we would have to increase one and decrease another one. So we would either have to increase either A or B, and we have to decrease either B or A. It's like saying, so by doing this, it's like saying we know some of A, so maybe we increased A, so we know more of A, which in this case might be position, but we know less. So decreasing B means we know less of the velocity. B can be velocity in this case, but we can't know both exactly. Like we can't know both exactly. Like we know everything about velocity and everything about position, because um, like the numbers can't be equal, okay? So a times b equals 10. A and b can't be two numbers, can't be the same number. So it's like saying we can't know both. We can know as we can't know both position and velocity. We either know more of one or we know more of less, or we know we know less of the other one. So the Heisenberg uncertainty principle states that it is impossible to determine with absurd precision, so total precision, and simultaneously two conjugate variables, the position and the momentum, velocity. If we actually try to measure them, in other words, if we measure the particle's precision and position and velocity, the values we get are defined by measurement errors, um, who, whose result is always larger or equal to h over 2, where h is the reduced Planck's constant. So Heisenberg said was and proved was that you can't know both the velocity and position of an electron at the same time. You can either know a little bit of one and less of the other, or vice versa. You can't know both of them. And yeah, and he proved it with an equation, which I'm going to put here. Where in this case the triangle is delta, so delta x, which is the uncertainty in the momentum, in the velocity, times delta p, which is the uncertainty in position, which is going to be greater than or equal. It's either going to be greater than or equal to h over 4 pi, yeah, where h in both cases is the Planck's constant. So it's going to be greater or equal to h over 4 pi, which is the same as h over 2, where h with that bar is the reduced Planck's constant. In what he said is, the more accurately you know the position, the less accurately you know the momentum, and vice versa. He proved that you can know both of them. Right? I hope I explained it nicely and that you understood. And yeah, see you in the next video.